Hi guys, so today we will be conducting a viscosity experiment at university level. This experiment uses a Brookfield viscometer as shown in the picture. This is because the Brookfield viscometer is a laboratory viscometer. There is a total of 4 spindles that is being used in this experiment. First is spindle number 1. It's the biggest out of the 4. The spindle number 2, then spindle number 3, and lastly spindle number 4.
The experiment, firstly, we will put in the sample, which is hydraulic oil, into a 600 mm beaker. Then attach the spindle used into the socket at the viscometer. Adjust the stand height before starting to make sure the spindle will be immersed into the fluid sample. Ensure that the spindle is immersed in the fluid sample until the line at the spindle cannot be seen. Set the viscometer speed to 60 rpm before turning on the viscometer. Turn on the switch, then flick the on button at the viscometer and adjust the speed according to the table at the speed required and desired. When taking the reading of the viscometer speed, wait until it spins around 5 times before taking the data. Press the switch when the red line appears after 5 times, then the meter will stop and able to take the data. Then change the number of spindle to complete the experiment.
Hi! Assalamualaikum.
We are from Group 5 L1P2.
And we are presenting about does peanut butter has viscosity.
I'm Iman.
I'm Nabila.
And I'm Hasha.
I'm Nurul Zafira.
Assalamualaikum. My name is Nur Hasha Damia, and today I want to explain about introduction of law and principle related to fluid mechanics. For our topic, does peanut butter has a viscosity? Okay, for the introduction, what is mean of viscosity? Viscosity is when two bodies in contact move relative to each other. A friction force develops at the contact surface opposite to the motion. As an example, if we want to move the table, we will move it in a horizontal line. For non-Newtonian fluid, the relationship between shear stress and rate of deformation is not linear. Fluid for which the apparent viscosity increase with the rate deformation are referred to as dilatant or shear thickening fluid. Okay, in general, the viscosity in fluid depend on both temperature and pressure, but the dependence of pressure is quite weak. The viscosity in peanut butter is a measure of its resistance of deformation. The first type is indicate 100% peanut is known as unstable suspension, consists of a solid peanut particle in peanut oil, which is Newtonian fluid.
Warahmatullahi wabarakatuh. My name is Nurul Zafira Iliana. So I will explain on the fundamental law related to viscosity of peanut butter. So peanut butter is categorized as non-Newtonian fluid, which is disobey the Newtonian law of viscosity. Butter is categorized as non-Newtonian, which the shear stress of the fluid increase. When the shear stress of liquid increase, the viscosity of fluid will also increase. This fluid refer to shear thickening flow behavior, and it is categorized as dilatant fluid. Dilatancy of frequently observed in fluid contain high level of deflocculated solid. In this case, the peanut butter is under non-Newtonian fluid and it is a dilatant fluid. So, the accepted mechanism of dilatancy is depends on 4 factors, which is increased particles interaction, which are concentration, anisotropy of shape, size, and density. Of flow fluid behavior, which is non-Newtonian, dilatant, pseudoplastic, and Bingham. And another one is the Newtonian fluid. So it is actually different when the fluid has different properties that makes a different type of flow, which is respect to flow properties. Fluid are classified according to the relationship between the shear stress and shear rate. So this graph shows how the fluid flow and how the shear stress and shear rate related. Shear thickening or dilatant of the fluid is a relationship between non-linear with zero intercept, but the curve is convex. The viscosity increase when the shear stress increase.
Today I'm going to talk about how viscosity is applied in industry. Viscosity is applied in industry through a viscometer. This is an example of a viscometer. The Newton's law of viscosity is applied in industry to the viscometer machine here. Viscometer is an instrument or a machine that is used in industry to measure one fluid viscosity. Based on the theory, viscosity is best described as a measure of fluid's resistance to flow. Overall, there are 6 types of viscometer. First of all, there is orifice viscometer, capillary viscometer, falling piston viscometer, rotational viscometer, falling ball viscometer, and vibrational viscometer. For this case that we are studying, we will be using a Visco OC100 rotational viscometer to measure the peanut butter viscosity, and RH6 spindle and a beaker. By using this viscometer, we will able to measure the peanut butter viscosity by immersing the element or spindle in the sample. Assumption for the peanut butter viscosity number is high. The viscosity range for the peanut butter is 150,000 to 250,000 centipoise. But it will also depend on the type of butter that we will be using. To get the specific number of viscosity range or specific number of the viscosity, we will have to specify what type of butter that we will use. And then for the experiment, we can relate with the university level of experiment, which the university level of experiment we will be using 2 types of sample of fluid, which is the oil and honey. For that type of experiment, we'll be using the Brookfield viscometer. This is because the Brookfield viscometer is the laboratory type of viscometer. The viscosity of this experiment is used to measure the viscosity of honey and lubricant oil. It is used to measure by using different speed and different type of spindle. So back to the peanut butter case, we can conclude that the peanut butter can be related with the honey, as the sample of honey's viscosity can be seen and measured at the smallest spindle used and lowest speed. The peanut butter viscosity will decrease as the shear stress applied on the sample increase. As stated in the blog, there are different types of viscometer used. To apply it in industry, you have to know which type of fluid and which type of viscometer that you will be using, so that you will get an accurate viscosity number. That's all. Thank you.
Okay, I am going to explain of how the law of viscosity is applied. Viscosity can be measured by a viscometer. A viscometer has a lot of shape and sizes. We have a laboratory viscometer and a industrial viscometer. Okay, in the food industry, products are being produced in large scales due to the high demand. So we need to find the viscosity in an efficient way. So this is where we use the industrial viscometer. Okay. In the the Newton law of viscosity must be applied to identify whether the fluid is a Newtonian fluid or a non-Newtonian fluid, because we need to know what type of pipelines that are suitable for the fluids to flow, because if we use a different type of pipelines for a different type of viscosity, the fluid might be damaged. Okay, next, fluid in food industry consists from liquid, aqueous liquid to pasty liquids. So this is why we need to know its exact viscosity so that we can produce the equipments needed to process them. Okay, this is an example of a viscometer used in an industry. It can be used as a large scale or a small scale. This is example of a laboratory viscometer.
Now I will explain on how the knowledge of this principle or law can be used to solve problem arises within the selected application. So apparently, according to the research status that the peanut butter disobey the Newtonian law of viscosity, because the peanut butter viscosity is 250,000 centipoise. So the viscosity does not rely on the shear stress. Peanut butter can be categorized as dilated fluid, which is increasing viscosity with an increasing shear rate. As the viscosity increases automatically, the shear rate of peanut butter will also increase. That's all from us. I hope you enjoyed and understand what we shared on the blog. Don't forget to follow us. And thank you and
Goodbye.
bye.